Hey guys, so today I am going to create a sheet metal part, and for sheet metal part you can start as normal that you do for any other part. You can just click Control N for new, or Control N and select the template sheet metal, but for me I have already done so. Even if you have selected any other template, you can switch the application to the sheet metal. To switch the application, you can click on File, and there your recent or most frequent used applications are here, and all application design sheet metal. These are three normal and most used applications, at least for me, and shortcuts for them are Control M for modeling. For drafting it is Control Shift D, and for sheet metal it's Control Shift M. So we can switch to sheet metal application by using these shortcuts, or by using this menu command. So before beginning the sheet metal part, we will have to define few things. We can do those like sheet metal thickness, relief, bend radius, and bend relief cutout, length, width. To do that, click on File, and into Preferences there is sheet metal option, sheet metal preferences. As per our model requirement, sheet thickness is 2 millimeters, so we will give 2 millimeter sheet thickness, and bend radius we will keep to minimum sheet thickness. Relief we can keep as it is. There is no relief being used here, so it doesn't matter we change it or not. Neutral factor for bending and unbending the sheet, keep it by default. There are few options that you can use when you are working for a big organization. You can create your own library of materials with properties saved to each material. So that list will come up here, and you can just shortlist your selection as per your requirements, and then you can select the final material from the results. So we are just doing it manually. So my requirement is 2 millimeter thickness, bend radius, and relief parameters. Click OK. Anyway, you can always change these things later as well. So, but it is good practice to do these settings in the beginning to avoid some unwanted results. So let's start. So as per our previous videos, we will just create a short strategy how we are going to do it. By looking at the ISO view, I will just start by creating a simple tab. Then I will create these cutouts, and then I will create flanges, and then this cutout, and then finally this small flange. And after this small flange, the cutout, the oval slot inside this small flange. Then our finishing features like radius is given here at the corner. These will be placed at the end, dressing up features. So let's start. As usual, we will start with the sketch and select the plane. For me this is okay, and my first sketch profile command is active already. Now let's use one center rectangle. From our last video we saw there is an option to create a rectangle from center. We have already used this option by 2 point. 3 point we will use in maybe another video where we need some angle. In this is the right opportunity to use from center. So from center, what dimensions I need? 290. So I will use width 200, height 90. I am typing the values here, as you can see next to my cursor, and by switching or to switch between these text boxes you can click on tab and move on. So our rectangle is ready. You can just place it, and before placing, just notice the horizontal vector or the arrow symbol next to my cursor, which will make sure that the rectangle I'm going to place will have horizontal and vertical walls. If you want it on certain angle, you can just type your angle in the angle box and your rectangle will be created on the angle. I just want to be horizontal, so I'll click here. So middle click to finish the command, and once again middle click to exit the command. So my dimensions are ready, 200 by 90. At this moment sketch is fully constrained and I do not have anything else planned for this sketch, so I will exit the sketch. Now first command in sheet metal, what we will create is tab. Tab is a base feature. This dimension will be picked from the parameters that we filled in the beginning. What thickness we will create the sheet metal part. If you still are not happy with this, you can use the local value. It will just enable the device, enable the text box, but we already done the settings, so we will use the global value which we set up in the parameters. Another thing you can pay attention to, in which direction you want to add the material to, in this direction or the other direction. You can flip the direction as per your choice. My plan is to add the material downside, so that this would be the top face adjacent or coincident with the datum. All the dimensions are from there, so I will flip or add the material to downside. Now click OK. My first tab is ready. So my first tab is ready. Then there is one more option I would like to show you. It will be in when we will create another tab. This was the first, so make sketch internal. Now our next feature we would like to add is the cutouts at the corners. The dimensions for them are 120 in the center and 50 in the center this side and 120 this side. Okay, let's create another sketch, or we can do the same way we did in our earlier videos to reduce the tree length. We can directly go to the command and sketch within the command. So I will sketch within the command. We'll use the same datum. I want to use the same datum. This button is to deselect if you have selected anything by mistake, and you can deselect all by clicking this option, this button. Okay, so I will create 4 rectangles, or you can create 2 and mirror them. Now we will use 2-point option. One is this, and the second is this. Let's not mirror, we can, or we will again cover one more command, mirror, in the sketch. So let's do some constraints to reduce the dimensions. I want this line to be equal to this line lengthwise, and same this line would like to have equal to this line. Now I will need only 2 dimensions, but these are not the two dimensions that I want. Let's mirror first. I want to mirror these curves. Look at the selection in the bracket. The bracket number says the 10 curves are selected, but I have two rectangles, it should have been 8. Now the edge also has been selected, which I do not want. Deselect, and to avoid that, it happened because this option selection extent is selected within work part only. I need that when I need to link my curves to existing geometry, but at this moment I want the selection to be done within active sketch only. Now if I select, only the active sketch content will be selected. 8 curves, 8 curves. Center line would be in the center, yes, and click OK. So now with D shortcut I will activate my repeat dimension command. Now I want 120 this side, so this dimension would be 120 and this dimension would be 50. So close the dimension dialog box. My sketch is fully constrained now. These rectangles will be used to create the cutout from the tab that we created. You can see in the preview this is what we wanted. Depth is okay. The normal cutout command is a little bit different than the extrude command in our modeling application. Maybe I will create another special video to demonstrate the difference, but more or less this curve shape of the icon tells the whole story. You can clearly see that in the normal cutout command we can create the cutout which is changing its shape as per the shape of existing profile. So that is the beauty of normal cutout in Sheetmetal. So we just want until next. There is no need to give any value. If you want to give a value, just make sure that it is more than our Sheetmetal thickness. So we will keep until next. Click OK. So our sketch is already inside the cutout command, and we can move on to the next feature, which is flange. Now flange is here next to the tab. Now we will create flange, and the height of flange would be 30 and 50. Okay, so 30 would be the smaller one, this 50, and the bigger one is 50 millimeter. Let's start. With flange command, you will have to provide the edge on which you want to create the flange, and your selection is important because let's see here there are two edges, this one and this one. It depends in which direction do you want to create the flange. Based on that, if you want just like my requirement, I want to create the flange downside or negative z-axis, I will select the bottom edge, then my flange will be created in this direction. Still, if you want to just move it otherwise the other direction, you can just simply double click on the node, or you can use this flip arrow reverse direction. Okay, the length we need here is 50, and one more good thing about this flange command is that you don't have to create individual flanges for each flange edge. If you have the same height, you can create the same flange for more than one edge. We will select the next edge that we want, this edge to create another flange on the other side which has the same height. Now another thing I would like to share here, as you noticed that we created our first tab with these dimensions 290. Now thing to notice is here 200 is from outer edges of the wall including the thickness. Same here with 90, it is including our thickness, the total width of the part. So we have the option to keep in mind. This is the option of inset. This will define where you are going to add the material depending on the selection of the edge. Now this is the requirement that we want the material to be added inside of the dimension of the existing selected edges. That's what I want. If it was not the case, we will have to ensure the dimensions that you are creating in the first tab, and if we have been given the dimension inside the walls, then I would have selected this option material outside, so that I create the tab from inside dimensions and add the material outside later on. Similarly, there are other options. Bend outside, it will start bending from the dimension you have created the tab, and material inside OML. So we will discuss about this option maybe in another video. So we want, at this moment it doesn't make any difference, so we want only the inside material so that our dimensions remain for the outside wall. Offset option is used for minor adjustments. If there is let's say dimensions are also maintained, but you still want to have some little bit difference from the edge, distance from the edge for the flange, you can do that here, even inside, even outside. Depends on the situation, these will be handy, but I try to avoid my personal preferences to use this offset option because it creates problems with the corner command. We will see maybe in future videos, but at this moment there is no such requirement. We will select 0 here and we will just click OK. Relief and bend parameters will be default. This is the same parameter we defined in the beginning here. Sheetmetal preferences, neutral factor, bend radius, and even relief depth and width, which type of relief you want. In this case we already created big reliefs, so there is no use of these bend reliefs because there are no adjacent or 90-degree bends that we are creating in the same command. If we would have been like this and this, then these options will be implemented. So we will see these in other commands, in other videos. We will do the selection once again, this edge, and you can see even if I don't have to, there is option to select allow selection of hidden wireframe, and the next one is to highlight the edges when they are selected even if they are hidden. So I have to select this one and I don't have to rotate my model, and I can select the edge that is hidden there. So 50 length, angle 90-degree, width option full. These are the option that you can create. They control the length of your flange. At the center will give you another option how wide you want, and let's see, this is the width of the flange, notice here, and these are the reliefs that we were talking about. But let's stick to the plan. We will cover it some in some other videos. Please excuse the background noises. I do not have a soundproof room for me yet, and some background noises sometimes can be. Okay, click OK, finish the flange and move on to the next flange. Next flange is for the height, we know 30 millimeters. This edge and this edge, height is 30. Click OK and we are done. Now we will create this cutout in the center. There are two ways we can create this cutout. I will try to cover this as much as possible in one command, but if it had some, but you can also do it in two commands, one for this side and one for this side, but we can control within one command by using the depth or the value feature for the cutout. So let's try to do that. So dimensions for this cutout are 30 millimeter wide, depth would be 28.29, starts from the center. So again we will create a rectangle. It belongs to the center, so we can start our rectangle from the center and roughly finish the rectangle, give the dimension 30 millimeter. This would be 30, and edge, it doesn't matter. Okay, in this case you can use the existing edge within work part only and use this two edges to be coincident or collinear. My sketch is fully constrained because whenever I want to create cutout, I also want to cut to this wall. That's why I use the outside edge of the wall. So let's come out of the sketch and use the depth. It is not until next, we want value, and value would be here given 28.29. Value is 28.29. So you can see the same cutout is made only with one sketch and one feature. Okay, now moving on to the next feature, there is one flange to be created. Now this flange would be 4 millimeter, less than 30 millimeter. 26 millimeter gap should be there. 18 millimeter height would be there. Height is from this top face. So let's create the flange. Another thing we would like to see is how wide this flange is. It is given 36 millimeter. So 36 millimeter from this edge, center width is 36. Now some commands will be useful here. As we can see, this is the line of the cutout that we just created, and the bend we can see that is outside of this cutout. Now as we saw in our previous command I was trying to explain, this option inset will be used here to create the bend outside. In this way our bend will start from the edge we selected. And now is there any relief given? Relief, there is no relief given here, so we can select the relief to none. Did you notice the relief is gone just when I selected from square to none? The relief has been gone. Now another thing, before I hit OK, I need to control the height, and the height is 18 millimeter, or the length of the flange 18, and 18 would be from which surface? See here, length preference. Is it the inside? You can see the little red arrow here, from the inside face or the outside, and we know it is from the inside face. This arrow points to the top of this face, and then 18 from inside is the right option for us. Now nothing else to be given here. My all requirements are done. I will click OK to finish this flange. Now to ensure that we have created the right flange, we can do a quick check here for the dimensions. Use the I'll repeat, simply to access the shortcut, or the quickest way to access the measure command is click anywhere in the blank space, left click, and there is the measure command. This is for recent command, undo and search button, undo, redo and search button. So we will use the measure command. In object selection, what we want to measure is this 26 millimeter. What 26, how we can measure? We'll have to use the vector. This face and this face, using the vector this. Now it is 26 as we want. So why vector? If you notice, if I do not use the vector, vector is used to define the direction to measure. Let's just see what's the difference. If I remove the vector, you can see it will measure by default it will measure the minimum distance between two selections that you select. Between this face and between this face, this would be the minimum distance, and we can see it is clearly 26 point something something, which will give a wrong impression because it is not in a straight line. This dimension clearly is seen that parallel to these edges, so in order to achieve that dimension we use a vector. Vector can be defined by using by default vectors that are given in this blue vector boxes. You can just remove these by clicking on this place if they are in the way. So this vector will do, this vector will do, or we already created in the beginning the rectangle horizontal to our by default datum, so you can always rely on your edges as well. So it is 26 millimeter. What else we can check? From the top face, the height of the flange. Let's reset. From this top face, the top of the flange should be 18. It is 18, but 0.11, it is the same case from this to this edge. It is not a straight line, you can see here. So to do that in a straight line, we will use the vector. Now we can clearly see the dimension is 18 millimeter from this face to this face. Alright, so we have successfully created this little flange here. So we will move on to create some radiuses. The bending radius is already R2. If you want to check, we defined in the preferences what would be the bending radius, and you cannot you don't have to select it, just place your cursor over the object you want to give the measurements to, and we can see next to the cursor the radius equal to 2 millimeters. Escape. Now most of our features are created. Now the dress up features will be done. For dress up features, we see that R5 is used here, here, and here, here, here. Inside there is a slot pending. So to create a slot, we will again switch to normal cutout. We can create a new sketch and use this face as a base for the sketch. Now the slot dimensions are 3.5 radius, 10 millimeter wide from center to center, and from top edge the center would be 8 millimeter. Now to create a oval profile, oval slot profile, profile command would be an excellent choice for me. I will start with the line command. Inside the profile, create a line, and now switch by clicking and drag to arc automatically, then again line, then again drag. Now if you notice, there are some symbols here. They indicate the constraints that are automatically applied to this sketch. Now let's give the dimensions that we need. I will switch to dimension command, repeat dimension by using shortcut D. From the top edge to the center, it is 8 millimeter. 8, yeah. From center to center, it is 10 millimeter, which is already given. Or we can use these dimensions that are already given. This is 10 millimeters and this is 3.5. Now you can see there is a little bit taper in this line, because if you notice, you can maybe back your video a little bit, and you can notice that when we created this line, there was horizontal symbol already there to create this line as horizontal. But when we finished this arc and switched to line again, there was a tangent constraint by default activated, but not the horizontal. So it ensured that these two arcs are connected with the line that is tangent to both the arcs, but it is not necessarily to have a horizontal parameter as well. We can do that by clicking it and selecting horizontal, or we could also would have done with many other ways, like we can just give these two arcs as equal radius constraint, then also it will have the same effect or the results. But now there is one auto dimension. We need to define how far it is from the edge, and we can see clearly it is in the center. So the quickest and easiest way is to click the midpoint from here and click more midpoint of the edge and make these both midpoints vertically aligned. So our sketch is fully defined with the given dimensions. Sketch fully defined, fully constrained, finish. Now we don't need to give a value until next is fine for me. Click OK and the slot is cut. Do you notice the two blue circles in the center of rotation? This would be very good option when you want to navigate around. By default, if you do not define your center of rotation, it will be automatically taken near about the center, or maybe it's the center of this total mass that we have created. But we can define our center of rotation even by right clicking and set the rotation preferences, and we can select where you want to I want to select here, then every time you will rotate, it will rotate by assuming or calculating the center from here. Now you can also shift this immediately. You don't have to, every time you want to define the center rotation, you don't have to right click and go to this lengthy process. You can simply, I want to clear, simply wherever you want to place your center of rotation, you can just before starting the rotation, you can just click your center mouse button and hold for few milliseconds. Just for example, let's say I want to create my center of rotation to this point. I will just place my cursor there, middle click and hold for few milliseconds, then start rotating. It will start rotating from that center of point. Like if I want to rotate from this point, I will click, oh, sorry, I will click and hold, and this middle point center of rotation will be picked from here. If you do not click and hold middle click, then it will by default will be selected at the center of the mass that we have created. Okay, so let's just finish the model by finishing our dress up features. All the radiuses that are in the dress up features are of 5 millimeters. So we will go to the break corner command. We will just ensure that it is bend or blend, not chamfer. We will give the 5 millimeter dimension to the radius. Now we will select the edges. There is a quick way. We can just simply select by dragging and creating a window around the edges you want to select. This is a good way to select multiple edges, but you'll have to be very careful about the selection. Just keep an eye on how many edges in the brackets are selected. I know these are 4, so I'm okay with the selection. Similarly, I can select one edge here, one here, one here, one here. These will be 2, one for this flange and one for the other flange, and similarly this and this. So these blends are done. There are also blends in the cutout. I can again use, now I'll have to keep an eye on the bracket, how many edges it selects. Only one, then it's good. Similarly, top view, want this edge. I think there would not be enough space for this edge. We will see. Okay, click OK. My edges are done with the 5 millimeter radius. Now I want to set preference here, set rotation. And is there any definition available for this radius? This does not look the same like this one. This is smaller, and I don't see any dimension for this radius. So probably this would be a smaller radius because the distance is not 5 millimeter from this datum to this face. Yeah, this is 2.5, so 5 millimeter would be okay. We can add to the existing command by double clicking and just selecting this edge. It will do. Okay, so it is okay. I was going to say something. Yeah, in the measure command, just we learned that when there are two faces we are using to measure, and if these two faces are not at the same height, then we will get the different results, and to compensate that we will have to use the vector to get the right dimension. But this is only the case of faces, and if you happen to have a datum in one of your selection, then this vector will be not needed and it will be automatically defined. For example, if I want to measure the distance from this datum to this edge, I will not have to define any vector. It will be always a straight line parallel to the edge of the selection, because the datum is infinite and it will always adjust to the location where your second selection is. The selection, our second selection is this edge. It will come to parallel to this edge or the height of this edge to create this dimension and serve the vector option. So you don't have to select the vector if you have one of the selection as a datum. So this is clearly 30 millimeter of total dimension. Okay, our model is ready now. You can, before saving, you can, for me, I have a good habit of positioning it to the isometric view, because when you save, there is a preview of this model will be saved alongside the file, and before opening you can see the preview which model you are going to open in NX. And that preview is always created when you click on save. The present position while clicking on save will be your preview. So I'll click on save. So my model is ready now. I hope you liked my video, and if you do, please like and share my video to your friends as well, and please subscribe my channel and support, and I will keep creating more and more videos for learning NX and many other applications, and we will deep dive into many more commands that are available, like bending, unbending, close corner, louvre, dimple, and there are so many. So thank you very much for watching, and we will see each other maybe in another practice session or another sample model to practice. Thank you. Bye bye.